So let us try to understand the concept of thermal resistance. Here we have shown a slab of width B. The heat is flowing in X direction, that is shown over here, from higher temperature towards the lower temperature. dt by dx is the slope or gradient. So here in this particular case, this dt by dx is known as the slope or gradient, or it is also known as the temperature gradient. So the heat is flowing from high temperature towards the low temperature. The boundary conditions which are there are at x is equal to 0, temperature is T1, and at x is equal to B, temperature is T2. Now according to the Fourier's law of heat conduction, it says that the heat flux is proportional to the temperature gradient. Now this heat flux is nothing but it is the heat flow rate per unit area, and it is proportional to the temperature gradient, that is how temperature changes with respect to the distance dx. And the constant of proportionality is known as thermal conductivity with a negative sign, because the heat flow takes place in the direction of decreased temperature or decreasing temperature. Transfer this dx on this side, so it is q by a into dx is equal to minus k dt. And now apply the limits or boundary condition. So at x is equal to 0 to b, temperature is from T1 to T2. So these conditions, they are applied over here on both the sides, that is on the left hand side for dx and for on the right hand side for dt. Integration of dx is x from 0 to b. Similarly, integration of dt is t from T1 to T2. Now in place of x, substitute the upper limit minus the lower limit, and in place of t, substitute the upper limit T2 minus the lower limit, that is T1. So you'll get q into b upon a is equal to minus k T2 minus T1. Take this minus sign inside, so it is k into T1 minus T2. So we can rearrange this equation in this particular form. So T1 minus T2 divided by b upon Ka. Now using this, we'll try to understand what is the meaning of thermal resistance. Now we know that according to Ohm's law, V is equal to IR, or I is equal to V upon R, where V is the potential difference and R is the resistance. We can compare the heat flow through this particular slab with this equation of the Ohm's law. So as shown over here, in the electrical technology, we are having the potential difference. Here in the heat transfer, we are having temperature difference, that is T1 minus T2. Due to this temperature difference, the heat flow is taking place. Due to the potential difference, here the current is flowing, and R is the resistance that is applied to the current flow. Here instead of R, we will have thermal resistance, that is RTH. So what is that thermal resistance? That we will try to understand. Already we have derived the equation, that is Q is equal to T1 minus T2 divided by B upon Ka. So compare this equation with this particular equation. So heat flow is analogous to current flow. Temperature difference is analogous to potential difference. And this term will be analogous to resistance. So B upon Ka, that term is known as the thermal resistance for the slab. So in this way, we can say that RTH, that is the thermal resistance, is B upon Ka, where B is the width of this particular slab, K is the thermal conductivity of the material of the slab, and A is the cross-sectional area through which the heat flow takes place.